Moving on to diffraction. Diffraction is the bending or spreading of waves around the sharp edges or corners of the obstacles or slits. To observe diffraction, we generate straight waves in a ripple tank and place two obstacles in line in such a way that separation between them is equal to the wavelength of water waves, as can be seen on the diagram on this side. After passing through a small slit between the two obstacles, the waves will spread in every direction and change into almost semicircular pattern as shown here. Also, note that the diffraction of waves can only be observed clearly if the size of the obstacle is comparable with the wavelength of the wave. This figure shows the diffraction of waves while passing through a slit with size larger than the wavelength of the wave. And as you can see, only a small diffraction occurs near the corners of the obstacle. We have discussed almost every characteristic of water waves. What better way to recall all that we have learned than with an example? So let's begin. A student performs an experiment with waves in water. The student measures the wavelength of a wave to be 10 centimeters. By using a stopwatch and observing the oscillations of a floating ball, the student measures the frequency to be 2 Hz. If the student starts a wave in one part of the tank of water, how long will it take the wave to reach the opposite side of the tank 2 meters away? As always, let's note down the things we know. The frequency f is 2 Hz, the wavelength lambda is 10 centimeters, and the distance to be covered by the wave is 2 meters. We have to calculate the time t the wave takes to move a distance of 2 meters. So the relationship between frequency, wavelength and speed is v is equal to f multiplied by lambda. The wavelength given in the example is 10 centimeters, whereas the SI unit for length is meters. So in the first step, we will write wavelength as 0.1 meters. The relationship between frequency and lambda will be used to calculate the speed, which is, for recalling purpose, v the velocity equals to frequency f multiplied by the wavelength lambda. Hence, v equals 2 Hz multiplied by 0.1 meters, which gives us the answer of 0.2 meters per second. So, the velocity of the wave is 0.2 meters per second. We will use the formula for distance, that is, v is equals to d upon t. Now, using the formula for time, t equals to d upon v. So, dividing 2 by 0.2, we'll get 10 seconds as the answer. Hence, it will take 10 seconds for the wave to travel a distance of 2 meters.